news and bad news. Good news is I was from the other town, so I was not late, so I can start the class on time. The bad news is I didn't eat anything after CDR in the morning, so I usually very sensitive and sometimes angry and the yelling when I'm hungry. So that's the problem. So please cooperate with me, and then I'm going to start the lecture first. Before I exhaust it, I write, as you can see, a lot of things. So even that's not all the things that we are going to cover today. There are a lot of things we need to discuss today. Okay, so please pay attention to the lecture. Today we are going to start the neurological, then followed by the deep learning. This method I'm going to use. I found recently found the reasonable difficulty level, and then so you probably have another deep learning textbook, which is a reference book here. But this all math is not easy to understand. But this one is based on the very basic theory. But if you took any math class before, I don't think it's very difficult to understand. So I'm going to, even I'm reading, and it's not very difficult. So after you take my lecture, so probably you are able to understand the contents of this one. So please, instead of using the YouTube video or the bunch of things, instead why don't you read the textbook? This is one of the well organized and I think not very deep in mathematics, but it has a reasonable mathematics that is based on the derivative and chain rule and so on. But I think that you can understand. Please read the textbook, this book. I think that you can find the PDF version. I'm not sure. It's recently published. So this is the introduction to the deep learning from the MIT Press. Okay. So it's not the same guy, but this textbook is a little bit tough to understand. But this is definitely one of the best textbook regarding to the deep learning. And then we are going to discuss as much as possible. Then the last 30 minutes, we will have the presentation. So, Hidok, why don't you let me know the 7:50? Okay. So then we are going to have the presentation for the proposal. I already graded and gave the comment and point, so you can address during your presentation also. Okay. Any question before we start? So if I have time, I'd like to demonstrate the card that we are going to use. Probably is after. I thought before the spring break, but I don't think we have a time. Also, you are busy for your midterm exam, and then it's almost ready for the project documentation. But it will be safer to start after spring break. I will check it again. Okay. So then also I ordered the 2 more cards which are not approved yet. So if we have 2 more cards, so we can use the same form of the project team. So then we can have the 7 teams, and we can continue. You guys can continue to work with your teammate. Okay. Any question before we start? Okay, so also I list the last minute update for the lecture note. Okay, if you already download the lecture note, please download it again. So especially for the deep learning part, every semester I update and add a not new, but I try to find the easiest way for students to understand the concept of the deep learning, because this is not the deep learning class, so you do not have I do not have enough time to explain each and every detail. So I'm trying to find the better and easier contents, and sometimes I make my own. So probably I do not make the class note based on this one. So probably the next semester I'm going to use this, but it has the last minute update. So, but there are a bunch of other that I used the previous class. So pretty much today I'm going to use starting with the very briefly. There is the old contents is to compare with the other the classification algorithm, the unsupervised learning, then the I think the 09 the neural network, this. Okay, before we start, to take a breath, I am going to do the one video. Can you hear? I don't think our. Not sure.
Computer system to learn. Some algorithms work better for certain types of problems. In this video, I'll be explaining how perceptrons work and how they are used to create artificial neural networks. This theory is based on a simplified version of how humans learn. In the human body, there are billions of interconnected neurons. Each neuron has an input zone that consists of dendrites that receive the incoming signals from other neurons, and an output zone consisting of axon terminals that output the impulses from the conducting zone, the axon. In between the input zone and the output zone, the neuron has a trigger zone, where action potentials are initiated. And only when incoming impulses exceed the impulse threshold of the trigger zone, an impulse will be propagated to the next set of neurons. This action generates an all or none response. So if the incoming impulses aren't strong enough, an impulse won't be transmitted. The perceptron algorithm is the heart of the artificial neural network, as it plays the role of a single neuron in the neural system. In artificial neural networking, we layer a bunch of interconnected perceptrons together to form a neural net. Neural nets are used for linear classification. Linear classification is when you have to separate classes from one another by drawing a line, any line that accurately separates them. For example, you have a graph plotting points of the average speeds of cheetahs versus tortoises. To classify which points belong to the tortoise, you would draw a line separating the highest speeds from the lowest speeds. All the values below the line belong to the tortoise, and all the values above the line belong to the cheetah. The art of artificial neural networking lies in calculating the location and gradient or slope of that line. There are many different strategies of figuring out the slope and location. Put a hidden layer and an output layer. The input layer consists of however many inputs you'd like your neural network to consist of. Each input has a level of importance, commonly referred to as the weighting. The weight of each input is adjusted after each loop or iteration of the algorithm. The sum of the inputs multiplied by their corresponding weights is then run through an activation function. The activation function has a threshold value that determines whether the output will be 1 or 0. In the case of our cheetah example, a 1 could mean that the input belongs to a cheetah, and a 0 could mean that it belongs to a tortoise. But how do we get to the stage where the computer can classify data? First, we have to teach it what the speed of a cheetah is, and what the speed of a tortoise is. This strategy is called supervised learning. Supervised learning is when you classify data for the computer to train it for unseen data sets. Small children are taught through supervised learning when they are taught the names of different farm animals, for example. The computer learns when the input's weights are adjusted. The way this is done is through a method called backpropagation of error. The error, by how far the weights were off, is calculated by comparing the computer's output value to the correct output value and distributing the amount of error across the weights. It's difficult to determine by how much our weights were off when we use a Heaviside step function, because it will always have a derivative of 0. This is why we turn to our trusty sigmoid function. The sigmoid function allows us to accurately determine the error of our weights so that we can more accurately adjust them for faster learning. The reason why it is more convenient is because it allows us to use a curve that runs between 0 and 1 instead of a sudden step. This allows us to compare the computer's actual value. The line will likely call the bias. The bias is interpreted as an additional input. It also has its own weight. This serves as the constant, similar to the constant in a straight line graph, y equals mx plus c, where c is a constant. Simply put, neural networks are just multiple perceptrons, each with more than one input, leading to one or more outputs that are taken in as inputs to the next layer of neurons until it reaches the final output layer. The final output of the neural network does not necessarily have to be a 1 or a 0. Multiple outputs are especially useful when it comes to computer vision and image classification, where you can have multiple possible classes. The outputs can be used to represent the probability of the image being classified as a certain class. In this video, you learned that computers can learn through a concept based on the way humans learn, called artificial.
Okay, that's it. Today's class is done. So Anyone who can explain what is a neural network from a video? The reason why I'm showing this video is it's not easy to understand within 5 minutes such a neural network. If you can understand, you don't have to take this class. Okay, so however, it's not very difficult problem to understand. So, but if you have the basic knowledge of the data mining and the classification that we have covered, so I think it's not the rocket science. So today we are going to see. So this is not a deep learning class. So I try to give the idea of the very high level, but that doesn't mean I'm not going to use the math, so I'm going to use a little bit math, but sometimes through the mathematics, if you understand certain problem and solve the problem, it's much easier than just the description, one narrative, okay? So we will see today mainly what is the neural. So I'm not very familiar with such a terminology, so, but you know that this is a neuron in the human brain. So think about how you learn something when you were a kid. So your mom is teaching and something, and sometimes punish and sometimes award. Then eventually you will learn what is the apple, what is the dangerous thing, what is the safe thing, and so on. How it works in our brain. So that the people, especially neuroscience, neuroscience, the thesis work for what is the mechanism of our human brain, the working system. Then they realize that it's based on the neuron. The neuron is kind of the input and output system. So input is called the dendrite, and inside something happens like the 0 or 1 or whatever. The action is the output of that. So when we learn something from the what? The sense. So human body has 5, 6 different sense, whatever. So through the eye, through the ear, and sometimes the feeling, and we received a lot of information through such a sense. And this neuron, in our the brain, there might be huge, the billions number of such a neuron. It's not just one, but they receive the input like something signal or whatever, then they keep some of the important. What is the important, by the way? Who decided? So if you remember, the training system, learning system, we can summarize the training learning system as a one word. Anyone who remember? Frequency. If something frequently happens, so we remember such a thing. Sometimes it's called a pattern. So we try to find such a pattern of something. So this is a bat. So there might be a pattern of this. There might be frequent similar thing happen a lot. So in our brain, so we keep that information, and eventually that information is saved as the knowledge. So this output actually through the cell body. So the human brain, the neural system. So the kind of the summarizing or training get the final output. So input is huge actually. So even nowadays, right now, you receive a lot of the information from me, or even your body, or the temperature and the atmosphere. But what you keep in the brain is very small, but it's an important thing. Okay, so that is how it works. But we don't know still exactly how it works. But 1960, 1950, so some of the researchers would try to mimic such a human learning system, the neural. So let's start with a very simple. So we are going to simplify such a neural system, the right and the axon and the cell body. So let's say that we have something input. So it's a really complicated one. But in our case, the simple case, we are going to use just a full input, for example, x1, x2, x3, x4. So this can be any number. If we convert this one into the computer system, it can be, for example, 0, 1, 1, 0, or it can be height, or the weight, and this is the color, and this is the frequency, whatever the information for one data item. So if you remember the first class, the data mining defined the first, what is the data? So database consider the data as a tuple or record or the data row. So data mining. So it's such a the machine learning system consider such a data as eventually x has the x1, x2, x3, x4. Sometimes we consider this as the vector. Okay, so one data item. So we have the input such a data item. Then, if we receive such an input data, or from the sense, or from the number, whatever, okay, after we receive the data, we try to consider which one is important, which one is not. Okay, when we decide whether this, let's say this is the information about the person. Okay, person. Okay, so we try to, just like the previous example, so we try to separate one group of person, another group of person. I'm not going to say this is handsome, this is ugly, okay? But anyway, the two group of the person. So then how can we decide? So we, based on the input that we received, we are going to decide the combine into one with one. Some of the weight. So I'm usually, when I decide whether this is a good guy or a bad guy, I usually consider whether the height is tall or the short. So this is a high, very high the weight. Okay, and let's say 0, 1, 2. That is like the computer system. So and another weight, and another weight. Okay, by combining such an information, we are going to decide something. Okay. However, that's not enough. Sometimes we have the information that is not represented by the element. Okay. So or the basic, the characteristic or internal characteristic. So we are going to add some of the constant value for all the data, which is called sometimes a bias. Okay. So if you remember, some of the guys already catch there's a bias, it's additional information. So it's kind of the additional information, all the data that cannot be represented by the x0, x1, x2, x3. So that is true. So if we add such the very basic, can be in the human brain system, it may be the generic, the information that is already fixed. Okay, so generically we consider that when you are going to marry, so you like the tall and the heavy guy. That is true because all human beings actually fight with the other animal to survive. They need a more powerful body and the big. That is kind of generic. So we can add such additional information and additional value B. Then finally we have a certain output. Okay, that is the output in the neuron. That is the axon. So start. Then based on this value, like let's say this is something 1, 0, 1, 1, and the weight is 0.7, 0.2, 0.1, and 0.4. Then finally we end by adding the bias value, additional value. So we may have the output. So this value is 10. If that is bigger than, for example, 0, okay, bigger than 0, then this is a good guy. Otherwise, a bad guy, like that. Okay. What if we consider the input data as x? Okay, the all weight as the w. Okay, actually this is the zero product. Okay, 0 x0 times w0 plus x1 times product w1 plus and so on. Okay, this is if we consider this is the matrix, so matrix the product. Okay, so we can multiply and add, multiply and multiply and then that is the action product w, the weight. Okay, plus we are going to add the bias. Then finally we have the output y. Based on the output, we are going to decide, okay, or classify. Okay. Have you ever seen this kind of thing? Yes?
Deep learning class.
This is very similar as y ax plus b. right? So X is the input and Y is the output. So we have the linear. So this is a linear system. So you learned in your elementary school, not elementary, probably middle school. So Y equal AX plus B. This is exactly the same thing. And also we have seen this one in the linear regression. The linear algebra is the fundamental of the math. Okay. Then based on that, during the linear regression, we do not study very details the linear regression, but the linear regression is what? For the independent variable, we'd like to decide the dependent variable. So how to depend? That is can be represented by the certain slope. Okay. Slope. That is the actual weight. Then the y-intercept. This one is called the bias B. Okay, it's exactly the same thing. Actually, the neuron style system, which is called this is called the perceptron. So our perceptron is actually linear classification, linear regression. If we consider the modeling, that is a linear regression. If we apply this one to the classification, it's a linear classification problem. So actually it's exactly the same thing, but it's a generalized. Okay, so to use this linear classification, linear regression for the first thing. So do you remember there's another thing we have seen and also we practice in the exercise lab? We do not use linear regression. Instead, we are using something regression. Anyone? Logistic regression. What is the difference? Logistic regression and versus the linear regression. Logistic is a 0, 0, 1. The output is a 0, 1. But this one, it can be the minus infinity to the infinity. So we don't know which one is which, but if output is logistic regression, if you remember, it's like this. Okay? So then it will be this 1 or 0. It will be easy to decide. It can be used for the classification. So when we have such output y, so we'd like to activate. So activation means we'd like to use such output for our decision, for our classification. So such just the number 100 or the 50 minus 10 minus 100. It's not easy to decide. First, somebody used the threshold, the linear thresholding to decide. Linear threshold is based on the output. Okay, the x is the input, so we have the output. If output is bigger than something, bigger than 0, for example, okay, this one is true. Okay, in terms of statistics, based on the hypothesis. So you remember the hypothesis. We do not use the hypothesis in our computer science area, but if you learn the machine learning or other, the statistical textbook use a hypothesis. It's the same meaning. But in terms of hypothesis, it's a positive, this one is negative. If the value output, the y is bigger than 0, then we are going to say this is the true, based on hypothesis. Okay? And the others are negative. So that is the linear thresholding. So we can use the linear thresholding, but it's not such the cut in half or such the arbitrary cut. So most of the cases. So instead, we are going to use something instead of such the minus infinity plus infinity. So we will make it convert to the 1 or 0. So the higher value we have, it's going to the 1. The lower value it has going to 0 converted. Then we can easily decide the 1 is a positive, 0 is a negative. So how can turn to the such a value into this one into this logistic regression? Anyone who read the article regarding to the logistic regression after the last class? So at that time, we are going to use really fancy, nice, the sexy function that is anyone who ever seen this?
Sigmoid.
I believe that all of you guys used this one in your calculus class. So what is the name of this? This is called the sigmoid function. So what is the characteristic of the sigmoid function? First, if you draw the graph, it's like this. Okay? And another thing, probably in your calculus teacher mentioned about that, one of the value of the, not value, beauty of the sigmoid function is the derivative is represented by this function itself. So why don't you try? So how can you make the derivative? What is the derivative of this? Anyone who can try? It's not very complicated. So if you, so 1 over x, can you make the derivative of this one? What is this?
Minus over 1 square.
Minus?
1.
So you can consider this one as what? Right? Minus, then 1 over
X square.
x squared. Okay? Then if you can do this one, then you can replace x by 1 plus e exponent at the e to the power of minus x. Okay? Then you can make the derivative of this and here. And also you can replace this and derivative of this. That's the minus e power of minus x. Then finally minus x. What is the mechanism? What's the name of that? This is called chain rule. So you can use the chain rule to make the derivation of this. If you cannot remember, why don't you open the older textbook if you have. Otherwise, check the Wikipedia. Okay, this is not. So I didn't explain the details of this in the master review, but it's not required to remember, but at least you should understand such a chain rule for the next the back propagation later. So this is called the sigmoid. So if we put the output of this perceptron into this one, it will be 0 to 1. Then we can easily decide. So that will be this kind of function is called the activate function. So there are different. We already learned the two activate function. One is linear thresholding. Another one is sigmoid. Okay. Deep learning definitely used this one of this, the activate function. So if you remember the last video, some of you already catch it. There little bit mentioned about the activate function. What else? There are several other, not many, several other. Just name is the tangent, hyperbolic tangent. What is the name of that? Hyperbolic, hyperplane, hyper something, tangent h. And we have tangent h is like if you remember, it's like this one. 1 through minus 1. Minus 0. I write to minus. So then you can use the tangent h or the hyperbolic, whatever. Then we have, you probably heard about this name, alialu or lelu or the rectify the linear unit. Rectify the linear unit is like we are going to make a 0 minus value but plus linear. Because even though there are difference, it's not much different here. So it's just slow to learn. Later we will see the epoch and iteration. So this one gives the linear, it's proportional, the gain of this. We will see. And there are several other variations. So we are going to use one of this. We already use this kind of the threshold. Every time we have the threshold. If your son got less than 60 points in there, the test, and kill you. So like the threshold, every time we use something threshold. But our curve is not fair. So because of that, we are going to use different activate functions. So go back to here. So we can use such an activate function and the bias and the input for the linear classification. That's it? That's it? It's not done yet. Why? How do we find this one? W and the B. So input is a fixed. So our problem is how to find W and how to find the bias B. So the perceptron system is kind of parameter. Like this parameter consists of the weight and the bias. So our goal is to find this. Then how can we decide? So for example, if output is, our expectation is the good guy is 1, bad guy is 0. Output is either 1 or 0. Okay? So if the input and the output is 1, that means it's perfect. Okay? If the output is 0, so it's it's really 0, bad guy. Okay? The weight is, the height is 5 foot, and weight is 100 pounds, and other information. But this one we know there is a training, so we know that this is a bad guy, 0. Then we got the 0. Then it's perfect. However, sometimes we got the 0.7. Okay. So because we are using this one is if output is here, it's a 0.7. It's very close to what is this good, okay? But not sure. Even if this data set has the label like the 0, it's very far. It's supposed to be 0, but it's a 0.7. Okay? Such a difference is called the error. If you remember the last video, the video mentioned about the error. Error means, so our expected output is 1, okay? So our expectation is 1, okay? So this one is observed data, so we are going to use a hat. So actually we expect the 1. Why is it 0 or 1? So after we got such a value, minus, okay? Minus, such a difference is called the error, okay? So if error is 0, it's a perfect system, okay? If not 0, that is a problem. Then at that time, we need to do something. So your mom probably teach again and again. You cannot eat but this one, you cannot this one, still you eat, and then sometimes punish, and eventually you learn until this parameter value is perfect. How? How can we? So linear regression use what? Minimize mean squared error. Do you remember? So that is also the same idea from here. So if we decide this, we are going to minimize this sum of this distance, mean squared error. So we try to minimize. That is one way. Okay? So that is optimization of the problem. So minimize the mean squared error. Something like that. Here, it's not easy. Okay? So people consider if the perceptron can address the perceptron, if we consider linear regression problem or the logistic regression or the linear problem, we can use such a simple thing, training. Okay? However, if the problem is more difficult or complex, this idea doesn't work. So that is one of the issues. So when after the perceptron was proposed, so it's not easy to train. Okay. Then to address that problem later, people think about why not? Based on this one, why not adjust this parameter. That's what we are doing. So for example, later we are going to use the car. Okay, it's not very clearly work the following the line. So we need to adjust based on the error amount. We try to change the P value, I value, the D value. So if you know the PID controller, so we can adjust such a thing. So we need to adjust. So idea of this one is why don't we adjust? This is called the learning evaluation. So to make this system this system learning system, we need to have such a learning mechanism. So for that, the method mechanism, back propagation was proposed. What is a propagation? Propaganda. So in social study, where such a thing, propaganda is kind of advertisement. So Hitler was one of the best guys for propaganda. Something proper. So it's like from here input to decide output is forward the propagation. Okay. However, we are going to back, okay, and check weight. Okay, check the weight, then the adjust, which is called the back propagation. Okay, how it works, why it works. So to do that, so we are going to cover this one. Okay. So then at this time, we are going to define the cost function. Cost function means, the sum of the error. Okay? Sum of the error. So, for example, this one is supposed to be the 1. So we have the input, and this one is supposed to be 1. So when we use this percentron, the output is 0.9. Then what is the error? It's 1. 0.9 minus 1. So if we have many of the percentron, we are going to sum up. Okay? Sum of the such a error is called the cost. If cost is 0, which means free, it's perfect. If cost is high, it's expensive. You need to pay. It's not good. Okay? So our goal is to reduce the cost. So if we consider such a cost, so we are going to use, because this is probably can be either plus or minus. So we are going to use, as we discussed before, square. Okay? So this can be cost function, can be y at minus 1 is represented by the square. Then if we have many of this perceptron, okay, n number of them, we can divide by n, average. So this is what? Quadratic equation. Quadratic equation. So you learn the quadratic equation probably your 6th grade or 7th grade. Okay, for your remind. Like this. Okay. Probably use different symbol, and what you have done, based on the quadratic equation, is you need to find this one. So what is the name of that? This point, right? So what is the main purpose of calculus? Anyone? Ever think about why do we need to spend a lot of time for such a stupid calculus? In my life, we never use, even though we are in the computer science. Not actually some of you guys probably is the first time to practically use the calculus here. So, by the way, why calculus is important? So, do you remember I mentioned about what is a math? What is a math? It's the language for nature. Okay? To understand the nature, we can use the math based on number and symbol, because it's perfect and simple and clear. Then once we represent, translate the nature problem in here, so somebody drop and this one and somebody explode and the energy and the E equal mc square like that, we try to make such the nature and everything with the equation or the mathematical notation. So, which means, so if we represent something, the problem with the function or equation, that is like the polynomial sometimes. Sometimes it's non-polynomial and but mostly polynomial. Not race, but polynomial. Okay? Like the speed or the area or the something like that. What we want to do is we try to understand such a curve. What is the characteristic of curve? So linear is the simplest curve. Okay? In the linear, mostly you spend a lot of time to find slope and y-intersection and x-intersection. Then that's it. You don't have to worry about each and every detail. Only this one and the y-intersection is enough to understand this kind of curve, this kind of nature. What about this one? You spend a lot of time, as I mentioned, you solved a lot of problems to find this. Okay? Also, later you learn if you derivate this, derivative is slope. What is a derivative? It's a ratio. Change. How does this curve is changing? This one definitely different from this. How much different? Based on the slope. How the slope is changing. That is a ratio. Then this kind of thing is called momentum. This slope is minus. Minus, 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 but it's the smaller close to zero, sometimes it's a zero. Then this point is a momentum to change it plus, it's a bigger. Then we can understand the characteristic of this curve, like the quadratic curve. So to understand quadratic curve, this is a very, the derivative, the calculus is the best way and easiest way, especially derivative. So when we have this one, this is a cost function. This is a cost function, g. Let's say our goal is what? Here or here or here? This one, because that means it's a zero, right? Zero means perfect, as we said. Okay, so our goal is to find this. But as we have seen here, first time when we test this system, it's probably a lot difference. So it's around here. Then here, where do you want to go? Going to here, going to down.
Yeah.
Going to down. We direct down, down, and finally going to this one. Okay? So how can we read this part? By changing, we cannot change x. Okay, that's the input. Okay? What we can do is change parameter w, weight, and the bias. Then, if we know how much this weight and bias contribute on the output, this one, okay, then we can adjust it, easily adjust, right? How can you find their contribution? Using derivative. It's a ratio. Okay, for example, if we have the cost function y, if we derivate this one, actually this one, partial derivative, because we have a multiple parameter w, okay, then this one will be 0, right? In the derivative, constant value regarding to w will be 0. And if you derivate, so x remain like that. So we can the derivative partial y, partial w. So this one is the contribution to this. Okay. Then can we find this value? Yes, because we know the y and the partial derivative. Then this one going to little bit step forward, okay? Step forward, until it is not changed or minimum. This is called the local minimum. our goal is actually not local minima. Local minima and global minima difference is like, our goal is to find here. But this one is also momentum, okay? If you derivate, this will be 0. So if you close to this one, it's no way to get out of this value, okay? So this one is called the local minima. This one is called the global minima. So our goal is to find this global minima, but sometimes the end with the local minima. That's also the frequently happen the problem in the deep learning. But so here, so our goal is in this case we have only one minima, global minima. That is our goal. Okay. At this time, this is called gradient. Gradient, little bit. Descendant. Gradient descendant, the mechanism. So little bit reduce finally to get the 0 value, minimum value. Okay? That is called gradient this algorithm. Okay? Then, what about the y? How can we calculate the y? It's just we are saying the minus y. Okay, is the observed value minus the expected value. But to do that, we will use cross entropy cross function. So we will see the more details of them. Then finally, we can find. But this is a simple perceptron network, simplest one. So it's not a big deal to calculate the partial derivative. What if like the human neural system is connected a lot? It's not also big problem using what? Chain rule. Okay? So for example, if X, Y, C, A, B, C. So this is our the finite cost. This is the input. And this is, for example, network. The neuron is connected. Our goal is to find and partial of the X. How can you calculate the X? X is based on Y. So we can calculate this one is Y and like this. And what about the Y? It's based on C, based on A, based on B. Okay? Eventually we can calculate by backward. We can find such a derivative. This is called backpropagation. Okay? So this one, benefit of backpropagation is we will see the little bit more detail. It's very simple. Some of the derivative already calculated. It's constant. And sometimes it's just one. If that is sometimes it's just one, and sometimes it's the very simple value. So we can easily calculate. Actually, not easy and not simple, but relatively easy to find such a derivative. Using such a derivative, we can do the same thing for bias also. Bias can be tuned, adjusted. Okay. Then finally, once we reach the cost function is here, this one is done. Then we can use the W and the B for the testing classification. At this time, each step is called in our training system is epoch. So you will see it's an iteration. One iteration, second iteration, third iteration, one epoch, two epoch, three epoch, and so on. So that is called the iteration also. Then we will use this one to understand. Oh, another thing is, so how much, even though we say there is a gradient descent, the descendant algorithm, gradient, how much gradient? How much small? Sometimes we want big jump, sometimes small. This is called the learning rate. So we are going to add one constant value. It's a learning rate. So we have another thing to be considered running rate. So running rate is many of the simple, the network use 0.001 or the 0.005, but it depends on the problem and the network. So, however, you need to understand, what about the huge size of a running rate? It will jump here. It will jump here. So you cannot, so actually, sometimes even though there's the global minima, you can jump over such a target. That is the higher problem of the higher running. What about the small?
Slow.
Really slow. It's like the turtle. Okay? And also, yeah, that's pretty much enough to understand the learning rate. Then, this is I tried to, some of the textbook or the narrative about deep learning is based on the fancy, nice, the network, very complicated network. However, you can understand most of the concept used in the deep learning and the neural network based on the one simple perceptron. Okay? However, this perceptron has a problem. What kind of problem? It can deal with only one problem, right? So output is either yes or no, like this. So we cannot use practically. So actually, this kind of problem, linear regression sometimes better, or support vector machine that we cover, that is much better performance. So neural network, so we can understand based on the perceptron, but perceptron itself cannot serve to address the problem of the other, the classifier. So why not combine multiple of them? So which means we have the input. Yeah? Instead of the one, so we have another one. So this one is connected and this one is connected. And if we need it, and like this, then final output is multiple. So if we combine the multiple perceptron, which is called multi-layer neural network, or sometimes it's called a multi-layer perceptron. So mostly we are going to deal with such a multi-layer, the perceptron multi-layer neural network. Okay. So I think that we mostly talk about the very basic concept of the. It's a very high level actually. I don't use a lot of math. Only the few of them I use. So you probably get the idea of that. So we will see a little bit more the theoretical part to understand that. Before that, softmax is before we start. Softmax is kind of the when we have the class problem like the cat, dog, lion, tiger we have. So when we decide based on the each one should have the activate function like the sigmoid. Then the output we need to decide which one is which class. Ideally 1, 0, 0, 0. This is what we want. However, it will not be. Okay? At that time it can be represented by probability. 0 to 1. Probability. 0.7, 0.1, 0.2, 0.3, like this probability. And if you normalize, like the sum of this, then the numerator is this one. Then we can decide it's a maximum value, not just a hard maximum, but based on the denominator. It's a softmax. That is the reason it's called a softmax to decide, okay, for the classification problem. So that is called a softmax. So most of the neural network use a softmax. Okay, any question? It's just an hour. Actually, this one usually takes 2 or 3 hours to understand, which means I don't think that you can fully understand the concept. Please read the at least the lecture note and or the textbook or reference book to understand that. Okay, I'm going to use the lecture note for the better understanding. So this is called the multi-layer perceptron network or multi-layer layer, the neural network. You can see we have the input, we have the output. It's not the perceptron one output, it has a multiple output. And between them, we have additional node. So this is called the input layer. This one is called output layer. Then the neural network has, in addition to input and output, it has a hidden layer. Okay? What is the idea of the hidden layer? So what is this node? What is this circle thing? It's a value. It's just a value. Okay? Think about the high level, not the graph as it is, not the equation, just a high level. We have input information, height and weight and color and so on. So this one determined to be input of this. Sometimes they are this one and this one. If height and weight are combined together, there's more powerful evidence to decide to be a good person, bad person, or the nice person, whatever. Okay? To decide a cat, dog, and lion. So this height and the weight can determine the strong. When you combine, there might be weight, there might be another weight. So it has each of the connection has the weight W1, W2, W3, W4. This one has W1, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2. Each of them has their own weight. Okay? Then when they combine, it's really strong weight. So this can be another input of the next one. So if we have the more complicated the characteristic to solve the problem, not just height and weight, sometimes combination of that. So we need such an additional hidden layer, okay, to catch such a characteristic. So each of them represent just a number, okay. It's also kind of another layer of input data. The problem of such a multi-layer, this one is called also the artificial neural network, ANN. So when you see the ANN, it's the same as multi-layer perceptron. Multi-layer, the neural network is the same meaning. But when you see this one, the artificial neural network, hidden layer is to solve the problem of the complexity of your classification. The problem of this hidden layer, we don't know how many hidden layers, how many hidden nodes, and in other words, the building topology of a network is very, very hard. Sometimes you need to test it this way, this way, this way, and so on. Okay? So there's no clear the general solution of this. Another problem of this, as you can see, how many weight value? If we have 1, 2, 3, so 10. This is a 10, for example. So 10 by 10. Already 100, right? 110 by 10 weight value only between input and the first hidden layer. And the same thing, this one and this. If we have the 10 node and 10 node, second layer, how many? 100. So 100 plus 100. And this is a 10 and 3. We have 30 weight value. And also we have bias. So 10 bias. Because in this case, we have only one output, so we have one bias value, but this 1, 1, 1, so 10, 10, okay? So 20, total 250 weight already. So complexity is very high, it's slow for training, okay? So that is the problem. Because of that, when I was a student, so my professor said you don't have to use the neural network because neural network provide reasonable accuracy, but it's slow and very hard to interpret. So such a just number, even though I said this is a characteristic combination of the height and weight, no, that's not true. We don't know such a value. If you run the same program next time, this one, nothing. It may be nothing. It's not exactly the same thing. So we cannot interpret, and it's just slow. There are a lot of computation. So we didn't use it. That is called the AI winter. The second AI winter. Okay, I will show you some brief history of the AI later, based on in terms of the the neural network. But this one is called the multi-layer perceptron artificial neural network. Any question? Okay, so these are the problems that we have seen. So we need a lot of training. That makes sense because a lot of parameter value. Okay, output can be discrete or continuous. That's not a huge problem. And may contain noise in the training example. So it's really long the training time. But the execution, testing is fast. One, testing need only one forward. Then if this one is the highest one, then you see that this side is a cap, like that. So testing is fast. Okay. So there are example of using the artificial neural network. This one was the classical project based on the artificial neural network ANN. So I did also using the grayscale images about it can be used for autonomous vehicle, the auto steering, like that. Then input is I'm going to explain a little bit more about the image before we start the convolutional neural network. Maybe after spring break. So we will get the input as each pixel value. Not all of this, only this part. It can take in this case, it explained the average of this one. So then we can train based on the shape of such a road. So whether we need to turn left or turn right or straight and so on. This is one of the classical example of using the ANN. Another classical example of the ANN is the classification of the handwriting, especially number. This one is very demanded because in US, so we are using a lot of check. So probably it cannot be processed manually. The system will recognize your handwritten, especially the number. If you recognize 1 as 9, it's a huge difference. So this one is the one of the example of using the ANN. Nowadays, if you start to learn the deep learning, so you can use the similar thing, MNIST, the MNIST data set. So MNIST, the data set is for the handwritten example. It's kind of hello world style, the deep neural network example later. Okay, so perceptron we already discussed, so you understand what is a perceptron and the gradient descent algorithm. So this is exactly same as this one, the perceptron that I use, exactly same thing. If there are input and the bias, and then we have the product of the input and the weight for each one, and the summation, then plus the bias. Then for the activation function, this one is the linear threshold unit. So then either the yes or no, positive or negative, and this side. So this is the simple perceptron. Then how can we train? So our goal is to adjust parameter value. In this example, we ignore the bias, but the bias can be considered as such a parameter. So we can consider the same thing. So delta, what is the delta? Delta is change, small difference. It's not smaller than the epsilon. Epsilon is the smallest. What is the definition of an epsilon? That is the first question being asked when I joined the first class of the mathematics department. The freshman. What is the epsilon? Even at that time, still I didn't know what is the epsilon. But the first class, my professor introduced the epsilon. I said this one. Without epsilon, you cannot define the limitation. Like you cannot explain the genomes, paradox, and so on. So what is epsilon? Epsilon is the smallest number, which is smaller than you can imagine. If you say anything, epsilon is smaller than that. Okay? If you say, or if you imagine whatever, then epsilon is smaller than that. That is the definition, really. Okay? So epsilon. So delta is not like the epsilon. Then eventually we are going to make the less than epsilon when we prove the limitation and so on. So we are not going to deal with such a detail. Instead, the delta is small. The difference, small difference in terms of this one. So little bit. Such the weight value we are going to assign the change of that by doing something smaller amount. Then our expectation is moving forward to the global minimum. Okay? So global minimum. Then at the time, how can you find this delta? The Wi, that is the T is our expectation, the one. O is output, the head. Okay? Then this one, this is the new. New is learning rate. Okay? Learning rate. And multiply by the xi, because if we derivate, so it has an x. So this is the small amount derivative. That is the idea of gradient descent, the algorithm. Okay? So this is called, if we apply, then at that time, if we had the multi-layer perceptron, it's not it doesn't look like that it's simple to find such a partial derivation, but by applying the chain rule, it can be easily calculated. We will see the example later. Okay? So running rate is sufficiently small. Mostly it's a 0.01 to the 0.05, our most popular running rate. Okay, so that's we can use the different activation function. We can generalize into the n number of feature and n number of weight. Okay, so using this. Then finally, our cost function is if we are using squared error, it's like this. Okay, the reason why we use the 2 is when we derivative, we don't want, because it's just constant. So we can put the whatever. But if we derivative, so this one will be gone. So that's the reason we are going to divide by the 2. Okay. So in case, so one of the difficulty when you read such the paper related to the deep learning, so they always start the general case, like the n number of case, because they do not have the enough space, so they just use the 0 to n number of cases. Then it will be hard to imagine. But it's exactly the same as this one. If we have the x and y, input and output, one simple perceptron, so if you cut this, then it's the same thing. Okay, don't worry about too much to understand such a thing, but it's exactly the same thing. So training rule is by applying the delta. So delta, that is so our goal is gradient is how much each way the effect, the E is the cost function. Okay, our goal is to adjust this one. So how to adjust? That is the delta. How can we get the delta? That is the multiply by the delta E derivative by the W. Based on that ratio, if that weight is important, then the more. Okay. If not important, 0, then nothing. Okay. That is then the move slightly. So that is our goal. The reason why you put the minus is if you derivative, it has the minus value. We will see that example. I'm going to skip this one, but if you follow the notation and so on, it's exactly same as the one perceptron case. Okay. So multi-layer perceptron. So we have the multiple, the output. Okay. At the time, the learning algorithm, learning mechanism is based on the backpropagation. So backpropagation looks like the very important, right? So we will see the more details of that later. So before that, so we have the different activation function rather than the linear threshold. This is the sigmoid. The sigmoid is one of the popular, but nowadays practically the LELU is more frequently used. I'm not going to this. This is a little bit harder to understand the propagation. But if you know, after you understand the very basic of the annotation and so on, this is one of the good example playground to understand. So if you go to the link, on the slide. So this is tinker with the neural network right here, whatever the name. So you can practice, simulate. So for example, this is a problem that is not linear. Even the multi-regression cannot solve this problem. Okay. So it's inside the derivatives. So at the time you can actually define the one more hidden layer and more node and the number of the learning rate at 0.1. For example, activation function we can use LELU, and regulation I'm going to explain the regulation later. Okay? And then the classification problem you can run based on the number of epoch. This is the error, so it's already perfectly classified. Okay, so this is the graph for the error. So along the different number of epoch, the error is almost zero. Okay, so you can test even too many. So you can start and you can do the one by one. You can see after the 8 times the epoch iteration, it's already classified. Okay, so that is the power of the neural network. So you can practice how to understand how the neural network is working using this example. Hidden layer is it was the problem to understand. So still the deep learning, one of the issue of the deep learning sometimes is very hard or almost impossible to interpret the meaning of the hidden layer. Convolutional neural network sometimes you can understand. We will see that example, but as you can see, even input is linear, output is linear, but the hidden value is almost looks like a random value. It's like a different random combination. Okay, so that is the neural network. Sometimes has the overfitting. Overfitting means it's as we discussed before. Overfitting means it depends on only training data. Okay, too much training, not generalized. Okay, so that has the neural network has the same problem. There are several ways to overcome such an overfitting. Okay, we will see how to overcome later. I like this slide. It's the better understanding. So you can see our perceptron is like multiple, the weight and plus one bias, and combine. Combine means the product and sum. Then we can have the output. So this is the perceptron. Multi-layer perceptron has the multi-layer. Okay, and it can solve the multi-class problem. And the deep neural network. Finally, we have the deep neural network. Deep neural network is much more the layer you have, and it can solve the complex problem classes. Okay, like the cat and dog using image. Why is more the complex problem? Because input, think about the input. How many values you have in one image? There are so many values. For example, if you are using the 800 by 600, okay? 800 by 600 is SD quality. So how many pixels, how many the element? 800 by 600, 48, 0, 0, 0, 0, 0. Even 1 point, it has 3 different values, red, green, and blue. So each value can be represented by 1 byte, so it's a huge number. So if we use one of these values as the input of the neural network, it's a huge, okay? So it was not possible to classify such a complex problem using the neural network. But nowadays, using such a deep neural network, not only is the complexity of the distant network, but also computing power. So as if you remind the backpropagation propagate reversely, and the check each and every way. So it's really huge computation. But nowadays, the way is using GPU. So GPU, as you know, is for graphic. Graphic is what is that? Array. So one of the main problem of the graphic is a game. So game, most of people want the without delay and display nicely, and it compute a lot of. It's a simple computation mostly. It's not complicated one, but it's like the matrix style computation. So we can adapt such an idea because when we have such a number of input, number of weight, it's like the matrix, right? So computation will be faster if we are using GPU. So due to the power of such a computation, we can finally implement such a deep neural network. So next class we will see the deep neural network. Okay, what's the deep learning? Still, some of the people they are arguing what is the deep learning. It's not very important, but in data mining class we tend to define the deep learning as a part of what? Machine learning. We have seen the conventional. So somebody says the previous approach for the machine learning are shallow learning. It's the opposite of deep learning. Shallow learning or conventional learning. Usually conventional learning, it doesn't require a lot of input. It's mostly we define the model or kernel sometimes called. The model, then the optimize. So we try to optimize such a kernel, then the use for testing. So that is the shallow, or that is the conventional way. It doesn't require a lot of computation, mostly simple. So when you have the reasonable size data, and also it's not very complex problem, still shallow learning conventional approach is better to you. Instead of deep learning, it looks like very nice because it's mimicking the human intelligence or brain. Not always. So somebody, like the Andrew, who is the kind of pioneer. Not pioneer, is the most popular, the researcher. He was I'm not sure whether still the professor at the Stanford, but the Andrew, right now is the founder of the AI company. It's a non-profit company. So last time he mentioned about the AI warning. So he said, do not publish the paper regarding to the deep learning. Do not research. Instead, please try to use. Okay. So the deep learning algorithm is pretty much the we have, So whether that deep learning AI technique can help the human life quality or not, something like that. Okay, so that is the deep learning. So this deep learning is one of the way to make the machine training. So then that includes the multi-layer perceptron, is an artificial neural network. We are going to, in this class, cover the two main, the very basic deep learning. One is the convolutional neural network to deal with the image. That convolutional neural network will be used for the second project. And RNN is the recurrent neural network. A lot of time, our data is based on the previous one. So when I'm saying, I am going, so you can imagine the next word. I am going mostly to, okay? Going to. So how do you know? It's a kind of pattern of series of data. It's not time series always, just a series of data. So if you, so think about when you read the textbook, there are researchers. So if you actually change the order of a word, even the letter of the alphabet of the word, you may not realize such a difference. Because when you read the book, when you get the information, you cannot actually catch each and every the information. Is that lovely? Okay? But there are patterns. So if we can catch that pattern, then we can imagine what will be the next one, something like that. Okay? So for example, every Friday night, okay, students get together for what? Party, like that. Not for study. How do you know that? We have information about the day of the week, Friday, it's a night, and we know that there is no more classes. So based on my experience, the last 10 years at UB, most of the students, the Friday night, they're going to party, like that. Okay? The kind of pattern. So that to catch it, to train such a thing, the RNN, recurrent neural network. At that time, sometimes I cannot remember the 20 years ago, 30 years ago. But usually the last few days, few weeks is more important. So if you remember the importance along the time, so it's called the LSTM, long, short term, the memory, like that. It's not the recurrent always, but sometimes the time. So we will cover pretty much CNN, RNN, and the LSTM in this class. Okay. So these are the guys who proposed the first time the neural network. If you want to go to the bathroom, you can go to there. So I don't want to stop the. So before I just finish my lecture, so feel free to go to the smoking or the bathroom, whatever. So these guys, they actually developed the software simulation for the such a perceptron. First one. That was the 1958, and the 60. There is the other line is like the neural network system. So by the Withrow and the Hope, and then you probably heard about the Minsky and Pepper. They proposed the perceptron, but so just like the reason I mentioned, so it's not the practically the possible sometimes to implement the perceptron. It's the first AI winter started at the time. AI winter means no money to research, okay? Because without money, even professor is not volunteer job. I cannot do, if I do not receive the money, I cannot publish the paper even. So the people, the industry, government, they didn't fund the AI because it doesn't look like the practical thing. Instead, they actually fund more practical thing. Nowadays, yes, but at the time, no. So, but people try to address the first problem, how to train. That is called the perceptron. Either that is the backpropagation. So, to understand such a backpropagation, I already implemented. So, this is a perceptron. Okay. So, such as the simple perceptron can solve the problem, linear problem, like this one. However, the problem of such another problem. This is a well-known problem in the AI. Can the machine learning solve the problem of what is this? Can you classify? This is called exclusive OR. The exclusive OR the operation means true, false. And if different, it's a true. So false, true. I think that should be mostly the so true, false, right? So true, true should be false. True, true, false, and the false, false, right? And this one is true. Which one is true? 1 is true or 0 is true?
1 and 2.
1 is true. So that means it should be 0. Sorry. I think that's the problem of the Hungary. Okay. Anyway, can you classify this one? Using linear classification? No way. In this way, so you cannot. So that was the one of classical problem. People said that we cannot solve the problem, the exclusive OR problem, classification problem, using the machine learning. But using multiple perceptron, it was solved. We will see. We are going to use exclusive OR to understand the multi-layer perceptron more detail. Okay, so this is the problem of the exclusive OR. So like this one. Input 1, 1, 0. If same, it's a 0. If different, 1. Different, 1. And the same, the 0. Like that is. So, this is the exclusive OR using the neural network. If possible, I'd like to use the whiteboard. But even I don't think we have enough time. But let me use the slide. To speed up. Okay, so using multiple perceptron, it's not connected, it's not network yet. Even though using the multiple perceptron, we try to solve the problem of the classification of exclusive OR. At this time, so these two are the input, like the x1, x2, 0, 0, 0, 1, 1, 0, 1, 1. So input. And this is the output. Okay, output is 0 or 1. So 0 or 1, 0 or 1, 0 or 1. So we have the 3 perceptron. But first we are going to use the 2 perceptron for the input. The third perceptron will be used for next layer of the perceptron. Okay, so to do that, x1, x2, x1, x2. At that time, what we need is the initial value of W weight. Okay, and bias. So these are the initial value, 5, 5, and minus 7, minus 7, minus 11, minus 11. And bias is minus 8, 3, and 6, like that. That's the same thing when you implement your neural network, deep neural network, the initial, the value of the W will be randomly created. There are research to find the appropriate such a way, but this time we are going to use a random selection. Then, what if we input this one? Where are they?
Maybe after your pen.
So for example, if we input is 0, 0. So 0, 0 is like this, and this is the 5, 5. So then the plus bias. What is the value? 5, 0, 5, 0. It's a 0. So minus 8. So if we are using the sigmoid for the activate function, so activate function is like this. So this is 1, this is 0. Minus 8 means it's almost 0. Okay? That makes sense. Then we input the 0, 0 again. So 0, 0, and minus 7, plus 3. So 3 means almost 1. Okay? So this is 1. So 0, 1. So we are going to use the output of these 2 perceptron for the input of the third one. So 0, 1, minus 11, and plus 6. So this one is minus 11 plus 6, minus 5. So minus 5 means It's almost a 0. So this one will be 0. That's the same, right? So similarly, we can do the 0, 1. One more, and 0, 1. So 0, 1, this is a 5, 5. 0, 1 is 5 minus 8. It's a minus 3. So this one is minus 3. If we apply the activate function, minus 3 means it's a 0. So this one is a 0. So this one is a 0. And 0, 1. 0, 1 minus 7 plus 3 minus 4. So minus 4 means it's a 0. So 0, 0, if we input 0, 0, and this is a 0, it's a 6. 6 means it's a 1. So this one is 1. So output is 1. This is the same. If you do the same thing, 1, 0, 1, 0, and 1, 1, 1, 1, this will be the same, like this. So we can solve the problem of the exclusive OR, which is not possible using the linear classification. Using how many? Using 3 perceptron. So if we combine these 3, like how can we combine? Input is 2. Okay? Then we have next, and final out, like this. So that is the, you can calculate the all of this. So that is the solving the exclusive OR. So we can combine into 1. This is a forward propagation. So 2, 1, 2, 3 perceptron. Then we can solve the problem. Then for the activate function, we can use the sigmoid. So kx is the output of the sigmoid function. Okay, and we can use the decision hypothesis 0, 1 binary problem. But problem is, as we discussed before, can we train the weight and bias? W1, W2. So we have the weight, and the weight, and this one. So bias. So can we train this value? Actually, this is a matrix. It's not just one single value because it's a multiple perceptron. So that is a problem using what? Back propagation. So we will see the back propagation. So to understand that, I think we already discussed most of this activation function and the weight and cost function. Eventually, I'm going to explain more about the back propagation for the running algorithm of the So these are the list of the things that you need to know at least before we start the deep learning. Okay? But the good news, we already covered many of them. We know the activate the function. We know the weight is the randomly selected. That is the weight. That should be the trained parameter value. It should be trained with a bias. And cost function, I don't explain the details. So, but I mentioned about the cross entropy, the function. So then also the little bit softmax. So I'm going to explain a little bit more about this one. Then finally, we need to learn that algorithm. But to understand the back propagation, we need to understand the several other things also. Okay, activation function. Sigmoid we already saw the 0 to 1. So and the tangent h, the I still cannot remember. Hyperbolic, right? The hyperbolic tangent is -1 to 1. Sometimes we can consider 1 minus 1 instead of 1, 0 means it's the hypothesis based on the hypothesis. Okay, positive or negative, true or false. But the tangent h, the hyperbolic tangent, can be used in case we need a -1. However, one of the problem of the sigmoid is even there are difference, it cannot be compensated. Okay. Because it's almost converging to the 1. So huge difference, but it's a positive difference. So can we get such an idea? The value actually the minus -1 is just ignore, it's a 0. But the positive case we are going to compensate for the cost function. Okay? And lucky early value I never use. I do not know much about, but it's a slightly compensate. Okay, and there are the other variation nowadays. The value is most popular. You can see that this is the example of the comparison between the sigmoid and the early value. We will learn such a similar program later, but it shows the 50% increase, but the early value quickly catch up the accuracy. In terms of such a cost function, this one is ideal, okay? Because cost 0 means perfect. So it's a short time, it is the perfect, okay? So this one is never decreased. So in this example, so it's a 90%, so 0.9. So early value, the other variation of the early value, like this. So when you read the technical paper or the article regarding to the deep learning, you will see a lot of this graph. So our goal is like this. So if you present the result, if you are using the deep learning, so you can show for the evaluation part, you can consider this kind of graph. So later we will see such a multi-layer, it's a kind of deep learning, and for the weight. One of the problem of the weight is, as I mentioned, I think before, when we backpropagate, when we update the weight, it is based on the previous one, based on what? Chain rule, okay? That means, so if we change 10% of this, and 10%, and that means 1%, and 10%, that means 0.1%. Eventually, too small number. Okay? So that is called the vanishing gradient. So if we apply such a back propagation, so weight sometimes, so weight of the input is no 0.00001%, 0.0000002. It's not much different. So we cannot differentiate. So at that time, so we can use the RNN recurrent means it gives a lot of weight for the previous one. Okay? So if I'm saying I'm going to, if we consider far away, it will be, doesn't matter, whatever you say. But when I say I'm going to, then everybody can expect the truth. No matter what I said before, like that. Then the sequence will be used. So we will see later this one. And also, the weight value initially randomly selected. What if the all 0? It cannot be trained easily. So there are the way to optimize the initial value of the weight at the deep brief network, or another one is this one, the restrict Boltzmann machine. They can interact with the next layer, something like that, but we are not going to cover that one. But this one is important to understand the backpropagation. So go back to our original idea. So our goal is to calculate the cost. Okay, cost 0 means perfect. High cost is not done yet, so we need to train. So that cost function can be represented by the different input and different of the expectation, so and our output. So then such a difference and multiply, not multiply. It's a square. Okay. The reason why we use the square we already discussed. It can make the positive value as well as exaggerate. Okay. There's such a difference. So then divided by the number of the input value is the m. Then the class. This is the number of classes. So if we add up all such a cost, that is the cost function. So this is the cost function based on what? X is a constant value. X input is not changing. Output is not. but the W, weight, and the bias, the parameterized. So then it will be like this one. At this time, it's not linear. This is a matrix. Okay, W is the n by n matrix, and the B is also the matrix, and the X is the 1 by the n, the matrix. So then this is ideal, okay, because this one. But sometimes if we use the sigmoid function, actually sigmoid function is like this. Okay, then we can overcome this kind of thing with the proper learning rate. So we can skip, even though we have the small local minima, so we can jump. So that is the cost function. So cost function can be represented by this. Then this cost function, first the logistic cost function is what's the meaning of this? Whatever the cost, okay? We use the square, the difference, then square, okay? So hx minus y and square, and divided by m. M is the number of the class, so average value for each class. Then what is this? Minus log hx. Hx, if y is equal to 1, output is 1 means what? True. It's good. Okay? And 0 is a negative. It's not good. Not good. Yes, not good. Whatever. So that means if y equal to 1, so y equal to 1 means it's a what is a logarithm? Logarithm is like this, right? So this is 1. If we minus logarithm, it's like this. Okay? So if output is the y is equal to 1, 1 means perfect. It's good. Okay? It's done. So cost, in terms of cost function, it should be 0, right? Cost function should be 0. So that is this one. But if you have for example, the output is the 5, okay? So that difference will be higher, okay? So if the output of the perceptron, multi-layer perceptron, whatever, this is 1, and so the calculation of this output is the 1. In case 1 is perfect. So 1 is 1, so the cost is 0. However, what if this one is 0? Totally wrong, right? It's totally wrong. So 0 is this. Then cost means it should be really high. Okay, once again. So if we have the cost function, that output of cost function, in case this is a true, positive case. It's a positive case. Output of that cost, the cost is 1. Then that means it's perfect. So output, the cost is 0. Otherwise, if this one is 0, supposed to be 1, but it's 0, means it's huge. There should be huge cost. So how can we make? Using logarithm function. Especially minus logarithm function, we can exaggerate such a cost using minus logarithm. So that is this one. Similarly, the y equal to 0 case means it's a negative case. So it should be 0. So in case of 0, perfect. However, in case of 1, it should be huge value. So how can we make that? Using similarly, we can use the like this. So logarithm, the opposite and shift, flip and shift. So that is this one. So similarly, so in case of 0, it's a perfect, and in case of 1, it's a the huge value. So by combining into one system, that is this. So you can see that y and 1 minus y. So in case of 0, y equals 0, this one is 0, and the only logarithm 1 minus hx. Logarithm 1 minus is in case of y is 0. But in case of y equals the 1 is this one is 0, and this one is 1. So logarithm of the hx will be remain. So this is a combination of this. So this is called the logistic cost function, one cost function. Then cross entropy function is simply it can be explained by we are going to use the logarithm. Why logarithm? What is a logarithm function? Why we use the logarithm function? Okay. Why? A long time ago. So when we measure the distance between the Earth and the Sun, it's too big number. Okay. So using the decimal, the system, so we need to use 1, 0, 0, 0, 0. So instead, we are just taking out the exponent. Then to use the exponent, we define the logarithm. So here, so using the logarithm, similar to this one, using the logarithm, so we can exaggerate the cost in case of the unexpected, the opposite value. Similarly, the cross entropy. Cross entropy actually let me explain the other. This one, even we don't start the backpropagation yet. Let me use the last 10 minutes for the backpropagation, and we'll start the presentation from the group number 7 this time. Okay. So let me skip, and I will explain later the cross entropy. We already covered most of them. The softmax is the average, kind of normalized by the all of sum. Okay. Running rate, overfitting. We will see the dropout and overfitting problem during the convolutional neural network later. Okay. Then the next 10 minutes, I'm going to quickly explain the backpropagation. So you remember this one. So our goal problem is whether we can train the weight and the bias. So to train the weight and bias, so idea is from here. The forward is the testing or the training, but once we have the difference cost function, so in general, the terminology, the cost function, that is the difference. So our goal is to minimize and eventually zero cost function. Then how can we make that the difference? So we try to use the derivative. Using derivative, we know what is the contribution of each weight by partial derivation. Okay, because that is a ratio. Then we can apply a little bit the difference, which is the gradient descent, the delta value. Then hopefully the cost sum of such the difference will converge to the zero. That is our goal. Okay. Then problem is how can we apply how can we calculate the partial derivation of the first layer, second layer, and so on. At the time, we can use the chain rule. So chain rule is, let's see this one. So our goal is to find F is the cost, okay? And derivation of the W means I'd like to know the contribution of the W to calculate the F, okay? And this one means I'd like to know the bias. how much bias contribute on this one. So we can calculate here the directly. How can we calculate? So first we can calculate the partial f over partial g. Because this g is the cost of the perceptron. Then we can calculate based on this one by adding the bias to this. We can calculate this. At this time, we can calculate this. How can we calculate? So we can like here. F is wx plus b, as we have seen the first time. And so if we write this one as a g, that is this one. This is a b. Okay. Then g is equal to wx. So which means the f partial of the g is, we can actually the g plus b, fg plus b. So g, and this is 1, right? Regarding to the g, if you derivate, this is 1. So this is 1. Then finally, if we calculate this, instead of calculate directly, we can do this. The partial f partial the w is g and the g of this. So f, this one is already calculated 1, and the GW we can calculate over here. That is the W. So that is the W is x, the coefficient. If you derivate, it's a coefficient. X is this one. So this value will be 5. So using the chain rule in the derivation, we can calculate step by step backward. So calculation will be easily implemented. That doesn't mean it's a simple calculation. We need to do a lot, but we have the solution to calculate the backward. So that is the back propagation. Then by adjusting the W, then forward again. Then to calculate the cost function again until it is the global minimum or the certain stop condition, like I try to do the maximum 100 epoch or the iteration, like that. That is the back propagation, the chain rule. So why don't you follow that the direction again from the lecture note. There's another the AI winter around the 2000. I think the 2000 we had the .com the boom up. So a lot of the company, including the Google and the mobile company, but at the time AI was not highlighted. But after we have the GPU and the hardware solution, we can have finally the deep learning. Okay, so let me stop here today's lecture. So I try to focus on to explain the very basic the concept of the neural network, including the perceptron, the artificial neural network, and multi-layered perceptron. We didn't discuss the details of closed entropy cost function and softmax, but we will have a chance to talk about them while we are talking about the convolutional neural network. Okay, so finally we can have such a deep neural network. Okay, let me stop here. Then let's move to the presentation. Please read, okay, at least the lecture note for your understanding. Then I will give the 5 minutes for each team. Let's quickly move to